The future of energy. Carbon dioxide is life. One of the biggest challenges we face in communities today is energy, and most of it comes from burning fossil fuels. About 85% of global energy consumed is from oil, coal, and gas, all derivatives of wood. We know that large amounts of carbon dioxide are placed into our atmosphere. But does carbon dioxide really damage the environment? In fact, the Earth has been more affected in the past by carbon dioxide through natural events, and has always balanced to normal levels afterwards. What is more surprising is that more carbon dioxide historically means more growth of the planet's vegetation. Is that such a bad thing? In fact, we know that releasing carbon dioxide was, and continues to be, a factor in man-made climate influence, one that results in more global vegetation, both on land and in the seas. It is in fact very simple to understand. Like in a tomato hothouse, the carbon dioxide in the air is breathed in by the tomato plant. Our life-giving oxygen is breathed out by the tomato plant, and we get the tomatoes. Whether we consider the small tomato hothouse or the much larger earth greenhouse, the process is exactly the same. Only the scale is different. If we stop the man-made carbon dioxide production of fossil fuels, the planet will produce it anyway, as shown in the record of Earth's climate history. So, what's all the fuss about? Real global energy concerns. Moving to clean and renewable forms of energy is a choice, not an urgency. The real concerns for our global energy future are around two areas. 1. A growing electricity demand in established markets, by about 2% each year. And 2. The lack of reliable electricity supply in low to no access regions, affecting about 9.6% of global population, or 768 million people. Features of a future energy source. Firstly, we can find ways to use less energy to create energy. The age-old physics problem. Not something from nothing, because that's impossible. No matter the energy technology considered, there is an energy consumption to build and supply that energy. It is this combined process that provides a more encompassing and totalistic view of the exact quantities of energy used to create any form of market energy. As we compare the technologies in use and in development based on modern physics and engineering capabilities, this full view of energy may be applied to discern their viability for marginal or mass adoption to the benefit of city populations. Next, considering the view in a perfect world, energy would be created as, where, and when it is needed. For such to be possible, an energy source would have to exist everywhere at the same time. A condition of engineering design where the energy source and its use are very close to each other. Another conundrum for modern physics and engineering, and a difficult riddle to solve in energy architecture. Alternative energy selection. Our choices for alternative energy sources have been focused on solar, wind, hydro, geothermal, fire fuels, and nuclear, each with its advantages and limitations. We haven't yet arrived at that perfected energy system, if possible, although we do strive to find it solve in physics and engineering. On the supply side, technology and policy drives energy transition, with the better technology driving policy, and not policy driving technology, in a reasonable operating society. On the demand side, there is only behavior to drive change. Focusing on the supply side, policy is positioning to adopt the use of hydrogen storage systems and fuels as the alternative of choice for our energy future, until something better comes along. Alternative energy goals. The goal of energy is to transform supply technology with supporting policy. 1. Using the least amount of energy possible to create that energy. 2. Placing the energy supply as close as possible to energy demand, with minimal infrastructure and operational costs. And 3. Providing a safe, clean, reliable, affordable, and accessible energy supply. What really supplies power to an electric motor? In order to search the possible technology solutions to meet alternative energy goals, let's look at the center of any type of electrical energy system. That is the standard electric motor. Consider that all nuclear, solar, thermal, wind, hydro, and fuels use the standard electric motor to convert those energy forms for use in power grids for homes and industry. To consider the electric motor, whether in a bicycle, car, or hydro plant, the materials in the actual engine are fixed, meaning once the engine is designed and built, there is a precisely known amount of reactive materials in that electrical engine or generator. On the basis that the amount of material in the engine is fixed, how is it then that a continuous stream of electrical charge may be driven through the motor system? The magnets, iron, and copper in an engine have only so much charge to give from its size. In fact, the continuous charge to supply any electric motor comes exactly from a redistribution of the ambient charge in the atmosphere. A seemingly endless supply of atmospheric ions, redirected through electric motors to keep our energy grids working. In fact, due to the Earth's coronal charge constant now determined to be 4.55 million volts, the atmospheric ion rains have a continuous charge supply to any point on the Earth's surface, with approximately 14,000 amps of direct current at all times, the true source of all electricity generation. Despite the mechanical or co-energy system used. Next-generation electric motors. As this charged ion rain is in consistent supply across our planet, if there was a way to convert this seemingly endless flow of these invisible ion rains more directly from the atmosphere into the power grid, then the electric motor system would be optimized, meaning the source of charge in the atmosphere would be directly connected to your power site, without any intermediate methods such as nuclear, hydro, fossil fuels, and so on being required. Such is now theoretically possible, and an engineering build design at Genie Aerospace for ground-based power reactors. A direct atmospheric ion conversion electric engine reactor. To understand the operation of a Genie engine is to understand two key things. Firstly, how a standard electrical motor works, and secondly, to understand the two types of inertia. On the first point, an electric motor works by transferring atmospheric ions to a power supply grid. A standard, bearing shaft electric motor will have one copper stator and one magnetic rotor. As such, a standard V8 diesel engine can produce 250 kilowatts per 380 kilograms of engine weight, or a power-to-weight ratio of 0.65 kilowatts per kilogram. A redirection of atmospheric ions into a power grid. Genie electric motors. The Genie electric motor is designed with two copper rotors with one central magnetic rotor, greatly improving the magnetic flux intersections in the engine system, attracting significantly more atmospheric ions. An engine system that more efficiently transfers atmospheric ions into a power supply. The advanced Genie electric motor is designed to produce an electrical output of 5,200 kilowatts per 8 kilograms of engine weight, or a greatly increased efficiency in the power-to-weight ratio to 650 kilowatts per kilogram of Genie engine weight. A more efficient redirection of atmospheric ions into a power grid. 1,000 times more efficient than a standard V8 motor. All achieved through the efficient, direct conversion of atmospheric ions into power. To fully grasp how the Genie engine operates, one needs to understand inertia in physics and its two types, namely, static inertia and dynamic inertia. The first, static inertia, operates to keep still objects still. The second, and more important for the function of the Genie engine, is dynamic inertia, operates to keep moving objects moving. Once the Genie engine is started, the free-moving, non-touching, magnetic parts are able to reduce friction to a very low value, allowing the moving engine parts to maintain very high speeds during operation. In fact, up to speeds of 400,000 revolutions per minute, or 7,000 Hz and more. as the engine is creating significant new electric power from high-speed rotation. And the loss due to friction has been minimized in specially designed electromagnetic settings. The new engine reactor produces a high net positive power value. But like any engine, Genie engines do require a power source to start the motor. This is accomplished using a battery and starter modifier system, very similar to a car. Except Genie engines may produce 1,000 times more power per weight of engine. A new frontier in energy technology. Remember, the goal of energy is to transform supply technology with supporting policy. 1. Using the least amount of energy possible to create that energy. Genie electric motors may be engineered to a power-to-weight ratio 1,000 times greater than standard electric motors. 2. Placing the energy supply as close as possible to energy demand areas with minimal infrastructure and operational costs. Genie electric motors may be placed directly next to any power demand, with minimal distribution and operational costs. 3. Providing a safe, clean, reliable, affordable, and accessible energy supply. Genie electric motors operate in safe direct current, without fossil fuels or exhaust. May operate reliably for extended service, with an economy transferred to consumer affordability, and with autonomous designs, making Genie engines accessible to areas without a traditional power supply feature or opportunity. In terms of the future of energy, the technology of the Genie electric motor checks all the boxes as a viable electric motor technology that may be sized to a variety of power markets, meeting the current and future needs of energy demand, including for homes and city power grids, for industry power grids, in aerospace, marine, and ground transportation engines, in equipment and appliance motors, for data center power grids, in robotic motors, and even in self-powering cell phones. Genie Aerospace, building skywards across the galaxy.